This is my walkthrough of the 4th and 5th programming assignment. Most of the code works except for one or two filters. I'm not able to show any visual example as I don't have a webcam available, but the code is tested with a webcam to see if the code is working. The first filter is invert, very simple, it changes color to the opposite of the original. Then there's thresholds, also very simple, it checks every color and see if the sum of the three color layers are above or below a set threshold. If above, the pixel is color white, if below, it's color black. Brightness simply adds more color value to the image. Same with brightness, just the exact opposite, it subtracts value from the pixel. Contrast, check if the pixel is below white when multiplied by a constant 0.667. If it is, then it sets the pixel value to the original multiplied the constant. Logarithmic grayscale calculates a standard grayscale first and uses the value in the logarithmic calculation to calculate a logarithmic grayscale. Same as the logarithmic grayscale, just use the exponential to calculate. Auto contrast, also known as histogram stretching. It doesn't work as intended. The idea is to take the lowest pixel value and set it to 0, and take the highest pixel value and set it to 255, and stretch the rest of the image pixels values to fit. This piece of code seems to work, but jumps between the right filter and different color layers. I suspect it's due to if sentence conditions are not properly set. Histogram goes through every color value for the entire image. Every time it finds a pixel with the search color value, it counts one up, and prints the search results in the draw function as columns. Elf blending defines an old frame from the graph frame and uses the two frames to calculate a new frame from about half of each of the old frames. This will result in a more transparent image frame. Background subtraction. The first piece of the code takes a snapshot of the frame and uses it to subtract the updated frames to subtract the color channels. When the filter is disabled again, the snapshot is released, and when applied again, a new snapshot is taken. Horizontal mirroring defines an old frame from the new and uses the old frame to define the newly grabbed frame with the width set backwards. Works the same way as the other mirror, just instead of flipping across the width, it uses height backwards. Mean blur goes through the image, jumping every third pixel and calculates in 3 times 3 blocks the average color value and sets the center of the 3 times 3 block to that value. This will blur the image. Like the mean blur, but this time it calculates 5 times 5 blocks and uses more color value from the center out. In the 5 times 5 block, all the color values are multiplied with the number seen in the two-dimensional array, and the sum is divided by the sum of all the numbers in the two-dimensional array, 273. Gaussian sharpen, using the kernel as before, but this time it sums up the values for each color, and then check if the sum RPG are below 1 or above 254, and sets the value to an appropriate 0 or 255. In the end, sets the three color tangents to the sums. Gaussian edge, using the same principle as a sharpen, but this time uses the kernel to check 3 times 3 block, and if the pixel in the center is high, aka white, the sum will turn into white, and leaving a white edge around various objects in the frame. Sobel, same principle as already explained, just uses different kernels. Same with the Sobel, the previous just uses different kernels to calculate. Median doesn't work as intended, should use bubble sort to figure out the fifth value in a 3 times 3 block and set the center value to that. Erosion checks a black and white image in 3 times 3 blocks. If the whole block is white, the center is set to black, but only if the whole block is white. Dilation works just like erosion, just opposite. Instead of removing the edge, it adds an edge. By checking 3 times 3 block for a single white pixel, if it finds a single white pixel in the 3 times 3 block, it makes the center pixel white. Grayscale, simple grayscale already explained in the logarithmic and exponential grayscale. Normalized RPG work by dividing the color channels with the sum of all 3 color channels and multiply each value with that 255. In the end, have all the 3 color channels run with all 3 colors. Track orange and pink. In the last part of the assignment, we were told to find the biggest orange and pink object and show the center of mass. Here's my way of tracking orange and pink, our color tracking code just searching for the RPG values of orange and pink. This code should then be set as a condition for a blob detection, and after the blob detection it should run through all the orange and pink blobs found and find the biggest. When the biggest blobs are identified, it should use the number of pixels divided by the total amount of pixels in the frame to get the center of mass. All this code we have done before.